We're going to take a first look at an operations model. Eventually, we'll be working with operations of many activities, but for now we'll consider an operation defined as a single activity. That doesn't sound like much, but plenty goes on even there. The summary output sheet looks like this. On the left are summaries of cost, inventory, time, and capacity. We're going to look just at cost first, so let's push the others out of the way. On the right are differences. When we change anything, the differences will be shown here. When you think about improvement projects, you can imagine this as the value of those projects. To play with cost ideas, we need a couple of types of input. The process type define things like waste and batch size. Inputs are color-coded blue text on a cream background. The green part shows the model's calculation of some process parameters. You can see the product defined as a pack with just one as the unit of sale. Packs will be assembled in batches of 2,500, 300 of which are wasted in a fixed manner and a further 15% wasted routinely. The cost tab has information on line speed, manning, labor and material costs. In this case, the line runs at 2 packs a minute, manned by 3 people, and takes half an hour to change from one batch to the next. For every productive hour, we have to pay another hour for non-value-adding activity. Labor rate totals $19 an hour, and the material included in the finished item costs $1.25 per pack. This is the sum of all the parts that go into the assembly. On the right, in green, the model calculates some cost categories for your information. Now we're going to play with some of these variables to see what happens to the outputs. Let's start with material. Suppose that wasn't $1.25, but it only cost us $1. I'm going to change that number to $1, go back to the summary output sheet, and now you'll see on the right hand side some colors. The fact that that has gone blue means that it's a good thing that's happened. In other words, we've saved some money. You probably didn't realize, but actually the figures on the left have changed as well. So looking back at the right hand side here, you can see that the number that changed was the material cost. Clearly we changed the material purchase price. The model reflects the unit cost difference because of that, and reflects the total cost difference because of that. So that one difference makes almost a 10% saving in unit cost. That's fairly straightforward. Let's play with a few more of those inputs to see what happens. Let's start with machine speed. If we double the machine speed, this has an effect on volume-related labor cost. This is because we haven't adjusted the manning level on it, so that same 3 people can produce twice as much. So the cost of the volume-related part of that is halved. As you can see, the final number is half the total. Let's try something else. We'll put that back to 2, just so that we don't confuse ourselves. Let's try changing changeover time. If that goes from half an hour to 0.3 of an hour, that affects batch-related labor cost. If we put that back to half an hour again, let's change the labor rate. Let's say that is 8.67. That changes volume-related cost, batch-related cost, but doesn't affect material cost. Let's have a look at another one. Put that back to 15. Let's go to the process sheet. Let's change that fixed batch waste from 300 down to 100. This has the effect of reducing material cost, volume-related labor cost, and batch-related labor cost. The batch-related labor cost is the labor saved from fewer changeovers. That takes a bit of thinking about, but we said the batch size was 2,500 and that's fixed, which means that you get 2,400 good ones out of a batch instead of 2,200 good ones out of a batch. So fewer batches make the product that we need. We can play with all of these, of course. Just for your information, those changes we've just made are from our book, Bridge of Faith for Operations. Those are exercises 1 to 5. We can play with all of those variables. We'll be doing some more later because those inputs have effects on inventory and time and capacity as well as cost, and we should be looking at that when we look at those.